Hello, this is Maria from mathmammoth.com. In this video, we're going to talk about dilations, which are geometric transformations that don't preserve the size of a figure, but they do preserve its shape. In common language, we call them just enlarging a figure or shrinking or diminishing a figure proportionally. Let's take a look at some examples. Technically, a dilation is a transformation where the distances between points in a figure are multiplied by a certain factor called scale factor. And a dilation changes the size of a figure proportionally, maintaining its shape but not its size. So let's say I take this chicken here, and if I just start dragging from the corner, Photoshop will enlarge it proportionally. Its shape will be preserved. But notice now, when I drag from this handle, it's enlarging only in one direction. It gets wider but not taller. That was not the dilation. One more time. If I do it like this, it shrinks, but not proportionally, not a dilation. But now it is a dilation. It enlarges or shrinks proportionally. Then let's look at this trapezoid, and I chose that one because it has parallel lines here. Now, when I dilate it, enlarge it, the lines still stay parallel, these two bases here. And the same happens if I shrink it. Yeah, still parallel. Now let's look at what happens when we dilate a triangle using different points, different vertices of the triangle as center points. Here we see a triangle, and this here is the center point of the dilation right now, but I can move it. So let's say that I move it over here to this corner, this vertex. And now, when I dilate it, you can see the original triangle there and then the enlargement. But you notice that the center point, that vertex stays where it's at. It does not move anywhere. Let's try it again, and this time I'll make it smaller. So the scale factor is less than 1 in this case. Now I'll do it again, but I'll move it to this vertex. Now we will dilate like that. Again, notice how that vertex stays where it's at. Or if I shrink it, one more time, the last corner, or the last vertex, I should say. Now let's take a look at what a dilation is in exact mathematical definition. A dilation always has a scale factor and then a center point from which the dilation happens. And this is how it works. I have here a triangle and then point P, which is going to be the center point of our dilation. And I'm going to enlarge this triangle by a scale factor of 2. To do that, I will draw a line from the center point of the dilation to each vertex, one at a time. Basically, I would need to measure this line however long it is and make it double as long. Whatever my scale factor is, I would enlarge this line by that scale factor. And where this line ends right here will be the vertex of the enlarged triangle. Now I'll do the same for this next vertex. I will now double it in its length. And where this line ends right there will be the second vertex of the enlarged triangle. And one more time. Alright, so now we have these points here and we can draw the triangle. Okay, there it is. The triangle is ready. Now I could erase these other lines so you can see it clearer. Okay, so that is a triangle that is double the size of the original, and it's been dilated from this point. If I had used some other point as the center point, then the triangle would be in a different location somewhere here. And for example, if the point P was further away, then this dilated triangle would also be further away from the original. And if the scale factor had been less than 1, then the triangle would have moved closer to the center point of the dilation than the original triangle. So, where the center point of the dilation definitely matters. Now I'm gonna just play around with this triangle and dilate it in different ways. And notice carefully how the location of the center point affects things. This is the center point of the dilation, and I can move it. For example, let's say I move it here, kind of far away from the triangle. Now I start enlarging it. The enlarged triangle moves away from the center point. And then if I start shrinking it, it moves towards the center point of the dilation and gets smaller. If instead I leave this inside the triangle somewhere, then enlargement goes like that. And shrinking looks like that. Let's try it one more time. I'll just leave it kind of near the triangle. Now enlarge. It moves away from the center point of the dilation, but just a little bit. And then shrink. It moves again towards the center point of the dilation. Okay, that's all for this lesson. I hope it was helpful.